what if we were able to open a C++ application like this one here I have created and type a value like hello world from C++ to Python to Pharo and pass the value to Pharo. See here? Hello world from C++ to Pharo. Now how I'm doing this magic? Now you may think that I'm doing this actually using sockets, which is actually a similar method I used for executing Python and using Python libraries from Pharo. But actually I'm using something that's much faster because sockets are not really that fast, and it's called shared memory. So what I'm doing here is basically I'm sharing memory, the exact same memory from C++ and Pharo. So both C++ and Pharo, the C++ application and Pharo access the same memory, and that means that each one has access to the data of the other application. And I don't really have to copy the data around, so that's one advantage. And another extra nice thing is that because it's using memory, it's using what's called map files, it stores this memory automatically without having to press a save button into a binary file. So exactly the same here we do with Pharo image. It takes all this data and put it inside a binary file. So the way it's doing this is, let me tell you how it's done this. It's actually quite simple. I have created here the example that I've just pressed to show you, which shows you the steps here. I create here the instance, we don't really need that. You actually can do this with, I have copied the same functions, methods to the class side and to the instance side. So if you want to create an instance, in case you want to create multiple mappings, multiple shared mappings, that's possible too, but in this case I'm choosing the simple way, which is a single area of shared memory. And I'm here opening a file which is located in this path, so you have to change the path if you have created a file with C++. And it's for reading and writing, and then I'm using this to define the size of the file. Then I'm using this to map the file, as you can see, map the file, which is the map file it's passed here with FT number, which is actually the number that identifies the file. So I passed it here FT number, and I'm saying that I wanted the address to start from 0. That means that the operation system will decide where exactly the memory will be located, and file size will be 4000, which is usually the size of the page of the memory, which is actually allows you not to waste bytes in essence. And I pass this flag, which means that I'm allowed to read the shared memory, I'm allowed to write the same memory, and the second flag, I'm allowed, of course, to share the memory, which is the most important thing, because if you don't share it, you cannot really access the same memory that the C++ application that runs now access. And what I'm doing here is that I'm using a structure that I've created to fetch the data. So because if you take a look here at the C++ application, it uses a structure. We can see here that says structure data. This is basically a structure is an object without methods. So you have here variables. The variable, the first one, stores the strings, which is hello world from C++ Pharo, and the second one is stores the size of the string, which I use the size in order to take character by character the string, and character by character are resynthesized in Pharo. So the size of the structure is 8 bytes, and the reason it's so small, it's because it only contains information about where data and count is located in memory. And that's it. And if you go here to cpstruct, which actually represents this structure in the memory, you can see that I already have created the character and the integer here and the count. And if you open here the file, let's see what it is. If we go here into the C++ file, you will see it's exactly the same process. Let's ignore, here's the structure. You see it's exactly the same. Character data, it's 3000 size and integer count, and the structure is named state data. And then if you go down here, it opens the file. See, exactly. I have tried to keep the C and the Pharo methods. Actually, the Pharo methods I'm using follow the C functions, and it passes here into an FD variable, which is actually just a number. It uses a number to identify the file. Again, the file path, which we define up here, which is, you see, mapped in bin, which is the file here. And then we have read write, then create in case it doesn't create, and then remember what those things. And this is a mode, and I don't remember these things. I think that's resize the file or something like that. So seek is actually, I think, it increases the size of the file to the file size. Then we write something to it, which is an empty string. You see, I pass the file once again, and I write it in the first byte. And then I close the file, so it actually saves the file for the first time. And no, sorry, it doesn't close it. Close it in case of error. So it continues, and then it maps the file. So actually what it does here, it takes the file and then finds a piece of memory, and then it maps the memory using the file size here. You see, I pass the file here, and I say protection read, protection write, which is exactly the same thing we said here earlier on. Please read the memory, write to the memory, and share the memory. And this is an offset. You can actually tell it to start from a specific address. From specific address. That's it. From specific address. Here 0 means that the operation system will decide where this address will be. And it can start from an offset from this address. So it doesn't really start from the start of the address, it can start from somewhere else if you want to. This can be useful if you want to have multiple shared memory areas, and that's it. And then here I type the information that I need, and here is actually how I pass the data to the memory. As you can see, I pass it character by character, and then I close the file. So it's actually the same thing with Pharo. There's nothing really different. Let's see if it will allows us to also, let me say here, let me go here. If I remember correctly, it must be, is it this one? No, it must be this one. Yes, that must be this one. So, if this one actually, if you take here this command and do it, no, sorry, inspect it, don't crash. Perfect. Okay. So what it does here is try to take an integer from the 101 byte. But this is not actually the nice way of doing it, because if you remember, we have already assigned 3,000 characters. So the best way to do this is self get handle. So what it means here, the get handle, this is actually the pointer. Okay. The get handle, it returns the address of the pointer, which is the most important thing, where it actually points to the data. And then if I put here unsigned character, unsigned character, because what I'm using actually is character, and let me put here this, and I say, let's fetch the third one, which is this one here, 3, and then I inspect it. You see, third one is an L, and it returns me an LL character. So if I wanted to change that, and I wanted to put a new value to it, then I'm doing the character, let's say the character to D. No, let's use small d. If I do this, and I'm going here, and let me open a new, let's see, cd Pharo. I don't want to stop the other file because it's sharing the memory. So what I'm doing here is I'm using another application to show me what kind of data it has in the memory stored. Print flags, let's call it print flags. So here you can see it has changed the string. So as you can see, both Pharo and both C++ can write on the same memory, and using the FFI and using the methods that I ported, you can exchange information with the C++ file. Now, why you want to do that? It's not that you can exchange data only. The nice thing is that if you are clever about mapping the data, you can even execute C++ functions, which is actually quite cool. The reason why I created the C++ bridge is because I want to use Unreal Engine from Pharo. And Unreal Engine is extremely difficult to build as a library. So the ideal way of using C++ code is to build libraries, share the libraries, and use the FFI, the unified FFI, which is the new FFI for Pharo. You can access this library as we do. In this case, we actually use the FFI to access the libc library, which is the one that gives us all these functions, map, lseek, open, etc., etc. This is the ideal thing you can do. And even with C++ libraries, it's possible to export them as C libraries and makes your life much easier. But if you cannot do this, this is a solution. This is actually a way to control a C++ application, and it actually can work with other programming languages as well. It can work with Python, also uses memory map files. It can work with .NET, which includes C#. It can work with Java, and probably it includes many, many more languages. Currently, C++ CPPBridge works only with macOS. Windows is doing map files a bit different, so I'll have to port it in Windows. But I will port it in Windows because I really need it in Windows as well. And it should work exactly the same on Linux. Now, if you want to install it, it should be in the catalog browser. Yeah, let's see if it is in the catalog browser. Not yet, but it should be soon enough. I have added the configuration, and it should appear at least probably tomorrow if you want to install it the easy way. Or you can use Metacello, and you can go to the GitHub repository, which is somewhere around here. So once more, we hear this actually way of working with C++ allows us to be much, much faster. The nice thing about share memory is that it's an operation system feature that is used a lot by the operation system. Operation system is using memory map files pretty much everywhere. Even the dynamic link libraries we use from Pharo actually using memory map files. And in many cases, some of the cases actually are shared memory files, which is exactly the same mechanism. And the nice thing about it is that it's extremely, extremely, extremely fast. So let's see if, yeah, here it is, GitHub. You will find it in my Kilon C++ bridge. And if you want the instructions, just take a look at the class site. Let's close this. In the class site, if you go to the comment bridge, you see here I have details, even how to fetch what the source code we actually analyzed earlier for the C++, and where you find the files. Actually, I have included the files as well, which is this one is the server we actually used. This one is the client, which is doing pretty much what Pharo is doing. So it's actually the C++ version. And this one is print flags, which it prints you the strings if you change the string from Pharo, and it allows you to see. And if you actually observe, we actually used 3 different applications. We have Atlas client, Atlas server, we have Pharo, and we have even print flags having access to this memory. So even 3 applications, 5 applications, and 100 applications. There's no limitation on how many different applications can share the same memory, and this is actually very useful if you move data around quite a lot. So that's C++ Bridge. I hope you enjoyed it, this screencast, and as always, see you around.